This whole addition process bridges to algebra. How? Well, once again, we have left hand equaling right hand. That's an algebraic thinking. We have this decomposition or expanded form. And then this all bridges to algebra when we start looking at letters. So we're going to take these numbers and convert them to letters. Since we are in what we call base 10, kind of an odd thing, but we'll be talking about that throughout the course, we're going to let x be 10. Therefore, x squared, if you're unfamiliar with that little notation 2 at the top there, what that really means is 10 times 10, which is going to be 100. If we go and look at this and we want to write 325 algebraically, we're looking at 300. There are 3 hundreds. In other words, 3x squareds, because x squared is 100. 20 means I have 2 tens plus the 5. Converting 142 algebraically, 100 means I have 1 of the hundreds. 40 means I have 4 of the tens plus 2. We're going to add this up. Looking at the hundreds, I know from what I did previously, I have 400. Looking down this left-hand column, I have 3x squared plus 1x squared. In other words, 300 plus 100 is 4 hundreds. Looking down the tens column, I have 2 tens plus 4 tens, 6 tens, or 6 x's. 5 plus 2 is 7. These two are equivalent in our numerical system, which we call base 10. So what you just did there was you added what we call a polynomial. That's algebra. Let's try another problem. Before I use my algebra, I have to convert. I must take this and write it in terms of the x being a 10 and the x squared equivalent to 100. So I would have 4x squared plus 5x, or 5 tens, plus 8, converting 236, 2 hundreds, or 2x squares, 3 tens, and a 6. Combining these through the addition process, left to right, looks like I have 6 hundreds, 8 tens, and a 14. So how does this correspond? 600, 80, 8 tens, and the 14. Now in the algebraic process, you are finished at that point. We do not say 14 is a 10 and a 4 and make us have 9x. We leave it at this process. Sometimes we might not let x be 10, so we leave it here. So we can have a singles digit as large as we want. We can have an x as large as we want, and we can have as many hundreds as we want. Let's try converting another one. 700 is 7x squared. 30 is 3x plus 4. Remember, x is 10. We're adding a 100, which is 1x, squared, a 4x, which is 40, and a 9. Combining, I have 8 hundreds. It's exactly what I have there. 7 x's and my 13. So once again, you are finished at that point. And one more. Translating it to algebra, 3x squared, where x is a 10, so x squared is 100. 6x plus 8 would be 368. Translating, 100 is 1x squared, 7x plus 4. Combining, I end up with 4x squareds 7x and 6x is 13x, and 8 plus 4 is 12. Notice how they match here. 130 is the same as 13 tens. If you had 13 $10 bills, you'd have 130. So that's the algebraic bridge from the addition process, from expansion or decomposition into algebra.